Hello everyone, I am Mrs. Padmashri from SNS College of Engineering. Today, as a lecture series, we are going to discuss the continuation of my previous lecture, AlexNet. So this is AlexNet, which comes under the CNN architecture, convolutional neural network architecture. As I already explained, I'll just give you the brief introduction about what is the AlexNet architecture. It is the architecture present in the convolutional neural network, one of the example architecture which has 8 layers with assigned weight. As we know, the neural network, each and every layers are assigned with weights, right? All the inputs are assigned with weights. So we have 5 convolutional layers and 3 fully connected layers, and as I said, pooling 3 pooling layers will also be present in the AlexNet architecture. So convolutional layers, normalization layer, fully connected layer, softmax layer is the output layer, and max pooling layer. These are all the layers present in architecture. Just for your quick reference, again I am going to project you the AlexNet architecture. So this is, you all know that is an input which is a grid like format, which mainly consists of the data in the form of pixel, which is a binary representation data which is going as an input to all the layers. So only the names of the layers alone I have explained, I have mentioned in my previous video. Here we will see how each and every layer is actually working in the AlexNet architecture, which is the convolutional neural network architecture. So input layer, convolutional layer, this is next. Between the two convolutional we have one pooling. The job of the pooling layers all I will be explaining in my coming slides. Then we have 3, 4 and 5 convolutional layer, pool 3 fully connected layers, and finally the output will get as a softmax layer. Okay, so a quick guide we can say on how many layers are there, how many filters are present in the layer, which all the layers the filters will be. So listed filter, the size of the filter and the number of filters used, number of strides, padding, output size and activation for each layer. So this is for easy understanding. I have just given. So we all know that the filters are present only in the convolutional layers, right? So there are 5 convolutional layers. Here you can see the input as 5 convolutional layers, and each convolution layer you have the filter size. Filters present in the layers, and the size of the filter differs for each layer. So see, you can see convolution layer 1, it will be 11 into 11, 5 into 5 for 2, and 3 into 3, 3 into 3, and 3 into 3 for convolution layer 3, 4 and 5. This is the size of the filter, and how many filters are there in each and every layer. It is not a fixed number. It may vary for each and every convolutional layer. One has a 96, 2 has 256, 3 has 384, 4 and 4 has 384, and 5 has 256. And how many strides? The strides I showed you, right, in my previous video. So the strides, we have 4, 1, 1, 1, 1, and the paddings are valid or not valid, and how many paddings are present to 1, 1, 1. So, and output, here you could see the with height and dimension how the output have. Output means we have a softmax layer. Okay, so the size of those layers 55 into 55 into 96 convolutional layer 1. Okay, and see, you can see the fully connected layer, we don't have filters for fully connected layers, and 1, 2, 3 and normalization layers. Only these has the size like width and 4096 we have. And so this is how the architecture is present. Exactly, the input RGB, image of size. We have 227 into 227 into 3. And output of the image, you have 1000 object categories. So the purpose of the convolutional layer, it is an artificial neural network mainly designed to process the images, that is the pixel data. Okay, and the first convolutional layer has a filter size 11 into 11 to capture the broader and low level features like edges and textures. So the job of the convolution layer is to filter, because filters are present, right, is to uh, design to process the pixel data, to filters, and also used to filter the unwanted pixel data, to cut the unwanted data, to keep only the necessary data we need. Next, what we have after the convolution, we have three pooling layer, right? Max pooling layer helps to reduce the spatial dimensions of data which is present in the image while retaining, and it keeps all the important features. It retains all the important features, mainly used to reduce spatial dimension. So the max pooling layer in the AlexNet has a filter of size 3 into 3 and has a two stripes. Next layer we have is normalization layer. AlexNet architecture, we have two local response normalization layers. There are two normalization mainly used to normalize. So from the name we can say normalization, mainly used to normalize the output. Suppose if the output we what we get is not normalized, we have this normalization layer to normalize the output. Use first and second convolution layer. So the LR normalization layer is present between the convolutional layer 1 and 2 to normalize the output. Next, the last portion will be the fully connected layer. FC1, FC2. Three fully connected layer